Let's use the formulas for area and volume. Let's use this function, arcsine. So let's draw it. So it's inverse sine function. Arcsine is like sine goes from 0 and on 2 pi interval. The values are, the y values are 0 to 1. So this one is reversed. So 0 to 1 will be the x values, and the y values will be, by agreement, because it has to be 1 to 1, therefore between pi half and minus pi half. Pi half minus pi half full. So it looks like tangent similar. And here minus 1. So here I got this value. So find the shaded area. So you want area and volume. And we do know that there are formulas for area. That's the integral itself. So area between, we said 0 and 1. Here is 0. So it's a normal integral between 0 and 1 of, and the function is called sine on the power minus 1, because of sine. So on of sine the power minus 1 of x dx. It looks pretty simple, but there is a problem. And the problem is simple, because what we know that the derivative of sine on power minus 1 of x by x dx is 1 over square root of 1, minus x squared. But that is different. Here we want so the reversal will be that the integral of this will be sine of minus 1, but that's not the case. This is like, it's impossible. Looks like we can't. It looks like we can't integrate it. It looks like, but it's not true. So we can integrate it. So how are we going to integrate it? So remember, there is a formula. It's called integration by parts. And it states that integral of, generally an integral of u times dv equals u times v minus integral of v times du. So notice here that they change places. So what it said that what's not under derivative, it's now under derivative. So it means if we apply that, we can solve this. Because here it was all contra. So if you apply contra to contra, we get it. So apply contra to contra. So we can do it. So we can do it. So what's u? So u is the one that we can't do much with. So that's u is sine on minus 1 of x. So what's our du? Okay, and what's our dv? Our dv is dx. Yeah. So that's applying to there. Okay, that's that. So what's our du? Our du, so if we can't integrate, we can differentiate. Yeah, and what did they said? Oh, we said that's 1 over square root of 1 minus x squared. And what's our v here? V is x. So let's try this formula, rewrite it. So we rewrite it as u times v, which is sine of 1 to the power minus 1 of x times x minus the integral of, we'll forget the boundaries for now, so keep them in mind. So, and now what's our v? V is our x. And what's our du? It's x over, that's that one there, 1 minus x squared times, and all of this is dx. Yeah, here I've got dx, right? So du is dx, right? So this comes with dx. These two come together, don't they? Let us now deal with this integral here. So the whole thing becomes sine minus 1 of x times x minus. So what's here? We can see that the power of x is less than power of 2. So for 1, so it looks like 1 divided by u, square root of u. So what we're gonna get at, so we're gonna make a substitution. We're gonna call 1 minus, so leave that for integral. Let's now just focus on integral, so we don't need this. So we're gonna say our substitution is 1 minus x squared, this x squared here, equals u. Therefore du equals minus 2x dx. Therefore x dx equals minus 1/2 du. So what we're gonna get, that this integral, we're just gonna do this integral, becomes integral of -1/2 du that's x dx, and under there we have u on the power 1/2, which is square root. So that's our integral. That is just the integral up to here. So this integral here. Focus on that minus sign there. That's not this sign here. And this integral becomes, so -1/2, and here we have u on the power -1/2. The -1/2 plus 1 is +1/2. 1/1/2 is 2, so times 2, and we have times u on the power of 1/2. So this is our integral. So this and this can be crossed. So the whole integral, the whole area now becomes, the first bit is sine on the -1 of x, but that's all within the boundaries of 0, 1. So times x minus this sign becomes plus u becomes 1 minus x squared, 1 minus x squared on the power of the square root of 1/2. That all between 0 and 1. So now we have sine of 1, sine, that's from here, sine, arcsine of 1 is pi/2 times 1 plus 1 minus 1 is 0, so plus 0. Now minus, for the value of 0, sine of 0 is 0, plus, so this always there, 0 plus square root of 1 minus 0, square root of 1 is 1. So it's -1, so it becomes pi/2 minus 1. And that's our solution. Our solution is pi/2 minus 1. That's our integral. The area. Useful formula, integration by parts. What's useful? Well, when something doesn't fit, when it can't do integral, it looks like it should be differential and vice versa. Let us find the volume. The formula for the volume is integral x equals a to x equals b of pi times that integral of y squared dx. And that's the volume when rotation around the axis. That around axis. The formula for rotation around the y-axis is just swap y and x here. Y and x here. So here y, here x, here y. So what does that become? That becomes our integral of 0 to 1, point in front, y squared, that's sine minus 1 of x on the power 2 dx. Okay, so let's do a substitution. Here y, because we have embedded functions, so we want to turn them to linear, so embedded functions turn to linear. And it's like to lose the power of 2. So what are you gonna do? Then substitution follows. Substitute. So what we're gonna say, Ru is equal to sine minus 1 of x. So what do we get? What's x? X is the reverse function of sine, so arc sine, which is sine. X is sine of x. Oh, of u. So we need to apply sine on both sides. So you get sine here and sine here. Opposite sine on the power minus 1 is opposite of there, so therefore you apply sine. You apply sine. Sine is opposite of sine on the power minus 1, so you get just x. And on the other side, you get, that's it. So what's du? So du oh no, what's dx actually, sorry. What's dx? Because we need dx. So if this is u, then what's dx? Dx is cosine of u. So what does this become? Pi integral of, so the boundaries will change. When x is 0, u sine of 0, arc sine of 0 is u. When x is 1, arc sine of 1 is pi 2. So u is pi half. So we have 0, we have pi half. So what do we get? Sine becomes u on the power of 2 times, and what's our dx? Cos of u, cosine of u, times du, of course, times du. So that's our integral. What do we see here? We have a product. So we can't do much with a product unless we break it into sum of something. But not only the product, we have the power of 2 for u. So what happens is, if now we want to bring it down, integrate by parts can come into picture. So that's second use. So, for example, integrate by parts says integral of u dv equals u times v, and then we have integral minus v du. So that's our integration by parts. So now, so what that tells us that, see, if the u is here, du loses the power. So square root, a power of 2 becomes power of 1. So power of 2 becomes power of 1. So we can use that here. So integrate by parts. This is integration by parts. So that's the second usage of it. In the lessen the lower the power. So what we're gonna do? Let's break this. So our u, which one we want to lower the u? So our u, in our case, let's change that to be easier. So I will say that rewrite this formula with f and g. F d g equals f g minus integral of g df. That's that integration by parts. So now we can remove the formula from here. So now we can rewrite. So we want f, so our f is u square. Therefore df is 2u du. And our dg is cosine of u du. Therefore our g is integral of cosine is sine. It's sine of u. So what do we have? Our formula will become pi integral of we'll leave the boundaries aside for now. So what's f times g? So this integral becomes pi times, and then we'll open the bracket, u is f, so u squared times sinus of u, that's fg, minus the integral of g sinus of u times df, that's 2u du. Okay, so let's resolve this integral. We'll keep our boundaries here. That's all in the boundaries of u, which is 0 to pi half. Now we have seen that using integration by parts, you can lower the power of the variable. So if you want to lose this variable, we'll apply the integration by parts. So what you're gonna do another substitution. So let's make some room here. So let's call them, instead of f and g, now k and l. So our u will be, or f or whatever. So our f will be k. So f is k. K will be, so instead of f we'll use k, and instead of g we use the l. So our k, the power needs to be lowered down, is u, and our dl is equal to du. Therefore, dk is du, and L is u. So what's that become? What does that become? Let's leave that everything and then just do the integral. The integral becomes, dl is, I apologize, dl is sine of u du, du times sine of u. Therefore, L is equal to L is equal to, we integrate this, so integral of sine is minus cosine of u. So what do we get? We get this integral. Integral becomes, integral here becomes u times v, k, we'll do it all in terms of u, so it becomes u times minus cosine of u minus, now the integral of, so just to make sure that we understand what you're talking, we'll change the color. I will say we're only interested in this bit here. So that bit there, that becomes that. Integral of, so now instead of k we have dk. Sorry, this is du, and we have, instead of dl, we have l. This is minus cosine of u, therefore plus cosine of u. So that over here becomes u minus u times cosine of u plus integral of cosine is sine. So now we can substitute back there. Let's make some room. And let's get some more room. So from here we get pi square sine of u minus 2 times this, so it's plus 2 times u times cosine of u plus sine of u (0 to pi half). So that becomes here we have pi half, pi square quarter, sinus of p half is 1, so we get pi square quarter plus cosine of pi half is 0, that's 0, plus sine of pi half is 1. The sine of pi half is 1. So 0. It's 1. 2 times 1 is 2. And minus of pi here, minus 0 is here. Here we have uh, 0, the first bit is 0 and the second bit is 0 2, so just that. So that's a solution. That's the volume. And just one more thing here, it was, see, minus here times that minus is plus, but this minus also with this plus gives a minus, so here it's definitely a minus. And here is definitely a minus. And let's do one more today, which is the length of the curve. So let's do the length of a curve. So arc length. Length of a curve. So the formula is L equals integral from A to B of square root of 1 plus dy by dx square. So let's do it on a more simple example. So for example, we do know that say, do it on a most simple example. Say the curve is straight, the function is, function is the most simple one, y equals x. And we want between the points 0 and say point 1. So what is the length of this bit here? So we can prove that you already know the distance between 2 points. Between the point is square root of x2 minus x1 square plus y2 minus y1 square. So the distance would be, that's our normal formula, and then we prove it that our integral formula will do the same. So 1 minus 0 is 1, so it's 1 square plus, and here is also 1, so 1 minus 0 is 1. So the distance is square root of 2. Let's prove that our formula will do it the same, and it will work for anything else. So what's dy by dx? For x equals 1, so it's only 1. X, first derivative is 1. So what the formula will look like? Okay, integral from 0 to 1, square root of 1 plus 1 square, and that's square root of 1, that's 1. Integral from 0 to 1, dx there, So integral 1 dx is equal to, what is it? It's x. So that x from 0 to 1, I'll square root here. So x on 1/2, right? 0 to 1, so x on 1/2, so it's 1 square root of 1. I apologize here, oh goodness. Here is square root of 2 dx, so square root of 2x x, and that's square root of 12 times 1 minus 0. Square root of 2, sorry. That's square root of 2.